In 1969, the spacecraft Apollo 11 landed humans on the Moon, for the very first time in history. The world has had to wait for half a century since then, before seriously considering going to Mars. The delay has been because Mars is simply too far from Earth, and we have had only limited knowledge about it. With the development of science and technology, over the last several decades, projects involving landing a human on Mars have begun. With many industrialized countries participating in those projects, in one form or another, scientists are making progress, but big challenges still remain. Going to Mars. Because Mars is more than 100 times farther than the Moon from Earth, reaching Mars requires serious hardware, including a powerful rocket equipped with extremely fast computers. For this purpose, a new generation of spacecraft is being designed and built at the National Aeronautics and Space Administration of the United States. Even with such powerful rockets, however, a round trip to Mars would be difficult, because it would take 6 months to go there. Even when the two planets are closest in their orbits, a round trip would take at least 1 year. Today's rockets and spacecraft cannot hold enough fuel for such an extended journey. While scientists are working to get around this problem, a European company has come up with a plan to launch a one-way trip with 4 astronauts to Mars, with additional crews joining them every 2 years. The world will have to wait several years to see if the plan works. Living on Mars. Humans need water, food, and oxygen to survive. We have much more to learn about Mars, although much has already been discovered. The most exciting finding about Mars is water, one of the most vital ingredients for life. NASA scientists have confirmed that Mars once had more water than the Antarctic Ocean, and to this day, some of it is locked up in Martian polar ice caps. Scientists are trying to find effective ways to get water from the ice. The next thing humans require is food. To produce food on Mars, we need special farming technologies. We can apply a special growing system that has been tested on the International Space Station. Of course, farming in space is not easy. Plants can be grown in space, but they require very careful management of gases, water, and dirt. On Mars, the challenge will be more complex than on the ISS. In addition to recovering water that is locked up in ice, the poor quality of the soil and the weak gravity of Mars need to be overcome. Therefore, success in farming on Mars might take decades or even centuries. Until then, food could be printed by three-dimensional food printers. With proteins and carbohydrates from various sources, such as insects and leaves, 3D food printers can print pizzas and bread, among other foods. A scientist at NASA predicts that there will be 25 to 50 basic food items. We're not planning for food at fancy restaurants, but just healthy and nutritious meals, he says. As for oxygen, plants might be used to produce it, and human waste might be recycled to provide nutrients for the plants. Until there would be enough plants to produce sufficient amount of oxygen, NASA plans to use specially designed machines to convert the carbon dioxide in the Martian air into oxygen. Protecting ourselves. Another important issue involved in going to and living on Mars is our health. Our bodies work differently in space. On Earth, gravity drags bodily fluids downwards, but in space this does not happen. The heart has to work harder during space travel and on Mars to compensate for the weak or zero gravity. In addition, weightlessness in space weakens bones and muscles. Astronauts on the ISS do a lot of exercise to avoid these problems, with additional help from drugs and artificial gravity from a spinning device. Similar measures will be used on Mars. One great threat to our body in space and on Mars is cosmic radiation. When we are outside the protection of Earth's air and magnetic field, we are exposed to cosmic radiation that damages our DNA and increases our risk for cancer. The plan proposed so far is to cover space vehicles with radiation-blocking materials, and to build shelters beneath the surface of Mars. Reasons for going there. The final question is this: do we really have to go to Mars, spending such enormous resources and risking people's lives? That is a reasonable question. Experts answer by mentioning two kinds of benefits Martian exploration may bring: practical benefits and a sense of our shared destiny as the human race. Practical benefits are economic, educational, and political. Space travel stimulates industry and draws people into careers in science and engineering. And while space exploration is a collaboration between countries to cover its high cost, having a space program raises any country's standing on the world stage. A sense of our shared destiny as the human race can be understood when considering the resources that are being depleted on Earth. We humans need to find ways to survive before we consume all the available resources on Earth. That is our shared destiny. Martian exploration can be seen as a step toward a human presence on another planet. It is not an easy, but a worthy dream for humanity. You can't really measure the value, says a scientist involved in a Martian project. If money is our only concern, everyone would study business. But we also want to give meaning to our lives. That's why dreams and passion appeal to humanity.